Welcome to our video lecture on limiting reagents. Our objectives for today, we're going to explain the concept of a limiting reagent. We're going to practice finding those limiting reagents using 3 different methods. So what even is this thing, a limiting reagent? Let's talk about some sandwiches. Let's say that my recipe for sandwiches is this: 2 pieces of bread, 1 piece of cheese, and 3 pickles. This makes one sandwich. If I go to my kitchen and I have 8 slices of bread, 6 pieces of cheese, and 27 pickles, how many sandwiches can I make? Think about it. 8 pieces of bread, 6 pieces of cheese, 27 pickles. 2 slices of bread per sandwich, 1 piece of cheese per sandwich, 3 pickles per sandwich. I can make 4 sandwiches, right? Because if I have 8 pieces of bread divided by 2 pieces of bread per sandwich, that's 4 sandwiches total. 6 divided by 1 slice of cheese per sandwich is 6 sandwiches total. 27 divided by 3 is 9. If I have 27 pickles, 3 pickles in a sandwich, that's 9 sandwiches that I can make. But I cannot actually make all 9 of those sandwiches because I don't have enough bread for 9 sandwiches. And I can't actually make 6 sandwiches with all that cheese because I don't have enough bread for 6 sandwiches. So I can only make 4 sandwiches because I'm going to run out of bread. Bread is what we call our limiting reagent. In this instance, I'm going to run out of bread first. It is going to limit how many sandwiches, how much product I can form. Good. All right. I'm going to have you do this one in the Edpuzzle. Same recipe, but now we have 12 slices of bread, 9 pieces of cheese, 15 pickles. How many sandwiches could we make? And what is our limiting reactant? So hopefully you took that 12 and divided it by 2 and got 6 sandwiches. 9 divided by 1 gives us 9 sandwiches with all that cheese. 15 divided by 3 pickles per sandwich is only 5 sandwiches. The highest number of total sandwiches that I can make is 5 because I'm going to run out of pickles first. Pickles is our limiting reactant. I have extra bread left over and I have extra cheese left over, and so I would call those in excess. I've got extra leftovers in excess. Pickles is limiting. So here in Edpuzzle, go ahead and define what is limiting reactant. Hopefully you chose the answer choice that was the reactant or reagent that runs out first, the one that limits the amount of product that can be formed. All right, so we're going to put sandwiches away and use this same logic, same problem-solving skills here in chemistry. So let's say that I'm looking at the synthesis reaction between copper and sulfur to make copper 1 sulfide. First up, we always need to balance our equation. We want to have our correct mole ratios. I've got 2 coppers in the products. Right now, only 1 here in the reactants, and so I'm going to put a 2 in front of it, and I now have 2 coppers, 1 sulfur on both sides. We have a balanced equation. So now let me think about, if I have 1 mole of copper and 1 mole of sulfur, what is my limiting reagent going to be? What am I going to run out of first? Notice that I have a 2-to-1 ratio, copper to sulfur. I need twice as much copper as I have sulfur. And right now I have equal amounts of copper and sulfur. I'm going to run out of copper first. Copper is going to be our limiting reagent because I don't have enough to react with all that sulfur. I can actually use my railroad tracks to confirm this like so. I'm going to start with my given 1 mole of copper. I'm going to flip that 1 mole of copper into moles of sulfur using my mole ratios. So I go up to my mole ratios. I notice that I have 2 coppers. I'm going to put 2 coppers on the bottom to get my coppers to cancel out. I notice that I have 1 sulfur. I'm going to put 1 sulfur on the top because that's what I want to find. What's going to cancel out is coppers top and bottom. So when I do my math, I have 1 times 1 divided by 2. 1 times 1 is 1 divided by 2 is 0.5. And my unit label is moles of sulfur. Moles of sulfur. So what I just figured out was how much sulfur I need to react with all of that copper. I need 0.5 moles of sulfur, but I have 1 whole mole of sulfur, but I only need 0.5, but I have 1. And since I have more than I need, sulfur is in excess. I have extra sulfur. And if sulfur is in excess, that means the other guy, that copper, is going to be my limiting reagent. I could confirm that one more time by flipping our sulfur and copper. So instead of starting with copper, I'm going to do the same thing, but I'm going to start with sulfur. My 1 mole of sulfur, and I'm going to flip it into copper. I have my mole ratios again, 1 sulfur, 1 sulfur. I'm going to put it on the bottom this time because I have sulfur on the top, sulfur on the bottom. We're going to flip that into copper. I'm going to put my 2 coppers on the top. 2 coppers because of that coefficient of 2 in front of copper in our balanced equation. So now what cancels out is sulfur top and bottom. What we're left with is 1 times 2 divided by 1. That's 2 moles of copper. This is how much copper whoa, that was too many E's. That's how much copper I need. I'm making it so much worse. I need 2 moles of copper. Let me try one more time. That's going to bother me. I don't know if that's better. Pretend. I need 2 moles of copper, but I only have 1. Since I need more copper than I have, copper is going to run out first. My copper is limiting. My sulfur is in excess. Good? All right. We're going to do the same problem now, but a different way. So this time, still with our balanced equation, instead of turning copper into sulfur, I'm going to turn copper into copper 1 sulfide, and I'm going to turn sulfur into copper 1 sulfide, and then we're going to compare how much product each can make. So I'm going to start first with my 1 mole of copper, 1 mole of copper. I'm going to flip my copper into that product, copper 1 sulfide. I have copper on the top. I want it to go away. I'm going to put copper on the bottom. I'm going to put copper 1 sulfide on the top. What coefficients do I have? My mole ratio, I've got 2 in front of copper and that invisible 1 in front of copper 1 sulfide. So here, copper has canceled out. I'm left with moles of copper 1 sulfide. And I can make 1 times 1 divided by 2. I can make 0.5 moles of copper 1 sulfide with all my copper. Let's do the same thing with the sulfur. So if I start with my 1 mole of sulfur, this 1 mole of sulfur, the other given, I'm going to get rid of sulfur. Sulfur's on the top, put sulfur on the bottom, converting again to that product, copper 1 sulfide. I have a 1, invisible 1 in front of sulfur, invisible 1 in front of copper 1 sulfide. This is super easy math, my friends. 1 times 1 divided by 1 is, yes, 1. 1 mole of copper 1 sulfide, because once again, top and bottom, that sulfur cancels out this time. So now I'm going to compare. If I use up all my copper, I can make 0.5 moles of copper 1 sulfide. If I use up all my sulfur, I can make 1 mole of copper 1 sulfide. But I can't actually make that much because I'm going to run out of copper at 0.5 moles of product, copper 1 sulfide. That means that copper is limiting once again. We're going to do the same problem one more time. This time, this amazing shortcut, this might be your favorite way to solve limiting reactants. So still in that balanced equation, and all we're going to do is take the moles of each reactant. It has to be moles, it can't be grams, it has to be moles. Take the moles of each reactant, divide it by its coefficient, and then pick the smaller one. What? Watch. So I'm going to take my 1 mole of copper, divide it by the coefficient of copper in the balanced equation is 2. That gives me 0.5 or 1/2. Do the same thing for sulfur. I have 1 mole of sulfur divided by its coefficient. That's a 1. That gives me 1. Because 0.5 is less than 1, copper is limiting. One more time. Good? So again, for this method, we're just going to make sure that we have moles, divide by the coefficient of each of the reactants, and the smallest one is the answer. It's limiting. Here's a problem for you to do in the Ed puzzle. I want you to pick your favorite method. Get ready, get set, go. All right, so you should have balanced with a 2 and a 2 here and here. I'm going to go ahead and do the shortcut method. So 1 mole of magnesium divided by that coefficient of 2 gives me 0.5. 1 mole of oxygen divided by invisible 1 gives me 1. Since 0.5 is less, magnesium is limiting, which means that oxygen is in excess. Good? All right, so now we're going to make things a little bit more difficult. We're going to do the same 3 methods, but instead of starting with moles, we're going to start with those pesky grams. If you don't have your periodic table and calculator, now's a good time to pause the video. Go grab calculator and periodic table. All right, so same reaction, but now we're working with grams instead of moles. Always, always, always we have to turn our grams into moles. So we're going to do that same first method. Our first method was take one of our reactants and convert it into the other reactant and then compare how much we have and how much we need. So I'm going to start with those 80 grams of copper. 80 grams of copper. Always, 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 we're going to convert our grams into moles. I have grams on top, put grams on bottom, and moles on top. To flip our grams into moles, we need to look at our periodic table. Copper is 63.546 grams per 1 mole. Handy dandy calculator, get it ready. We're going to cancel out grams top and bottom. I have moles of copper. As soon as I have moles of copper, I can flip my species using the mole ratios. I've got copper on top. I want it to go away. I'm going to put copper on the bottom. I'm going to flip it into my other reactant, that's sulfur. There's a 2 in front of copper. There's an invisible 1 in front of sulfur. And so now I can cancel out copper top and bottom. I have moles of sulfur, but I want to compare to grams of sulfur. So we're going to add one more piece in our railroad tracks. Turn those moles back into grams. I've got moles on the top, put moles on the bottom, turn my moles back into grams. We know that sulfur is 32.066 grams per 1 mole. So now I can cancel out moles top and bottom. We're left with grams of sulfur, and that's going to allow me to compare to how much I have. So with my handy dandy calculator, we're going to multiply everything on the top, divide by everything on the bottom. So I've got 80 times 1 divided by 63.546 times 1 divided by 2 times 32.066 divided by 1, and that's going to give us 20.2 with our sig figs grams of sulfur. Grams of sulfur is the unit label that we have left. So this is how many grams of sulfur I need to react with all of that copper. This is how many grams of sulfur I have. I have 25 grams, but I only need 20.2 grams. That means that I have excess sulfur, and if sulfur is in excess, then once again, copper is limiting. Copper is my limiting reagent. Sulfur is in excess. The nice thing about this method is that I can pretty easily calculate how many grams of sulfur I have left over. If I had 25, but I only needed 20.2, then I'm going to have 4.8 grams of sulfur left over. 4.8 grams of sulfur in excess. Good. So that was method number 1. Take one of your reagents and turn it into your other reagent, and then we compare how much we need with how much we have. Same problem. Second method. Second method was convert both of our reactants into the product, and then whichever one makes less product, this is our winning limiting reagent. So 80 grams of copper. 80 grams of copper converted into moles of copper. Molar mass of copper, 63.546 grams on the bottom, moles on the top, so that we can cancel out grams on top and bottom. I have moles of copper. As soon as we have moles of our given compound, we can use our mole ratios to flip it. So I'm going to put that copper on the bottom to make it go away. This time, method number 2, we're converting to product. Copper 1 sulfide on the top. I have a 2 in front of copper, invisible 1 in front of copper 1 sulfide. So now I can cancel out copper top and bottom. I'm going to go ahead and add one more little piece, and I'm going to convert my moles back into grams. But this time I'm not talking about copper, I'm talking about copper 1 sulfide, so we're going to have to do some math. I need 2 coppers, which are each 63.546 grams per mole, plus 1 sulfur, which is 32.066 grams per mole. With my calculator, 2 times 63.546 plus 32.066 gives us a grand total of, oh my gosh, this is big, 159.158 grams per mole. So here we can cancel out moles top and bottom. I'm going to do some math with my calculator. Multiply everything on the top, divide by everything on the bottom. 80 times 1 divided by 63.546 times 1 divided by 2 times 159.158 divided by 1 gives us 100.18, lots of digits, 100 grams of copper 1 sulfide. We're going to do the same thing, but now we're going to do with sulfur instead. So I'm going to use my 25 grams of sulfur. I'm going to convert my grams of sulfur into moles of sulfur. Grams of sulfur, 32.066 grams per mole. Grams on top and bottom cancels out. As soon as I have moles of my given, I can use my mole ratio to get rid of that given, my sulfur on the bottom. I'm converting each of my reactants into product. So I'm going to put sulfur on the bottom so that sulfur cancels out. I'm converting it into that product, copper 1 sulfide. So back to my mole ratios, I have a 1 in front of copper 1 sulfide and an invisible 1 in front of sulfur. This is going to be easy math. Good. So now we have successfully canceled out sulfur. Top and bottom is gone. I have moles of copper 1 sulfide. Let's go ahead and convert those moles back into grams. I've got moles on the top, put the moles on the bottom, put the grams on the top. Here's a nice thing. We're still talking about copper 1 sulfide, just like we talked about it here. We already have that molar mass. It is 159.158 grams per mole. So now, just like we did above, we're going to multiply everything on the top, divide by everything on the bottom. 25 times 1 divided by 32.066 times 1 divided by 1 times 159.158 gives us a grand total of 124 grams of copper 1 sulfide. Since 100 is less than 124, if I go back to the beginning of this problem, copper is limiting. It makes less product. It limits how much product I can make, and so copper is limiting. Guess what we're going to do? This same problem one more time. But I'm going to use method number 3, which is quick and easy. I'm going to take each of my grams, turn them into moles, and divide by the coefficient in the balanced equation. So 80 grams of copper, flip that into moles of copper, 63.546 grams, because that's the molar mass in the periodic table. That's going to give me 80 divided by 63.546, 1.26 moles of copper. I'm going to divide that by the coefficient in the balanced equation, that's 2. So 1.26 divided by 2 is oops, sorry, that's wrong. I should use my calculator. Sorry, is 0.629 coppers. So hold on to that number. We're going to do the same thing for our sulfur. So sulfur, 25 grams of sulfur. I've got to convert my grams into moles. Sulfur is here, 32.066 grams per mole. Grams top and bottom cancel out. I'm going to use my calculator. 25 times 1 divided by 32.066 gives us 0.7796. Let's round that, 2.780 moles of sulfur divided by the coefficient in the balanced equation is 1. That leaves us with a 0.780 sulfurs. Since 0.629 is less than 0.780, copper is once again our limiting reagent and sulfur is in excess. Good? All right. Your turn. Pick your favorite method and do this example in the Ed puzzle. We did it! We explained the concept of a limiting reagent. We also practiced those 3 different methods. Method number 1, I can convert one reagent to the other reagent, and then I can compare my need and my have. If I need more than I have, it's limiting. If I have more than I need, it's in excess. Method number 2, we converted both reagents to product. And then I picked the reagent that made the lesser amount of product. That one's limiting. Number 3, this one is a nice shortcut. We converted all our grams of reagents to moles. Divide by the coefficient in the balanced equation, coefficient, and then the lesser one is limiting. Good work today.